So what I did was I recorded three things every single hour for a 48-hour period in the middle of January in Indiana. Three things I recorded were the time of day, the presence of clouds, but also the temperature. And so those are the three things we're going to observe throughout the course of this 48-hour period. We'll start off with the idea of cloud albedo forcing. Okay, I'm going to put this all in motion, so some things I want you to note. Not only so much the time, but notice the temperature on the surface, the temperature there above degrees Fahrenheit. So think about the role of clouds and its effect actually on temperature at the surface. So now the sun is set. It's now 8 p.m., and so no longer do we have that insolation hitting the surface. But also, at this time, clouds now leave the area. And so some of the things you would have noticed throughout the day was that clouds were over this area for the entirety of the day. And also, temperature really didn't change that much. It only went down a few degrees Fahrenheit. Now let's see what happens overnight when we have the absence of clouds. Here we are now at dawn, 7 a.m. the sun is starting to rise. This will be on average the time we would expect to feel the coolest temperatures on an average day. And so we see here 0 degrees Fahrenheit, and so overnight temperature dropped considerably. Key to understanding that was the fact there were no clouds. There was no clouds acting as a blanket trapping in that heat, and so our temperatures got quite cool over the evening. But let's see what happens when we have no clouds during the day. Now let's look at cloud greenhouse forcing. Here we are at 4 p.m., the highest temperature we'll record during the 48-hour period, and this makes sense. This is during the afternoon where we had all day long of incoming solar radiation having nothing blocking its path as it reached the surface. But at 6 p.m. we have the arrival of clouds. Now pay close attention to the temperature as we have cloud cover coming into the area over the evening. Now we're down to only 27 degrees Fahrenheit with a whole night of cloud cover in the area. And so compare this to the previous day when we were at 3 degrees Fahrenheit at 6 a.m. Today, next day, 27 degrees Fahrenheit at that same time. This line graph tracks temperature change throughout this 48-hour period. And just by looking at this, I can see when we had cloud cover. And we can see cloud cover, whenever that line is the most horizontal, or doesn't change much at all, we can see that that's the role of clouds. And so clouds do a good job of moderating temperatures. Whereas the absence of clouds, when we see from 7 p.m. On the first day all the way till 5 p.m. the next day, with no cloud cover, we can see big temperature swings, big temperature extremes. And so key here is understanding the role of clouds and its impact on temperatures